Still in the hunt. Still in the hunt. Okay, today, we're dealing with section 6.6. Now on Friday, now you won't have this next slide, which is the goals. You won't have this one. But what we're going to be going into today, we need to finish up those theorems we started the other day, 621 to 624. I believe we got the first two, correct?
Yeah.
Today we have to do the next two. Okay. We're not going to get to them all today. I thought we would. So one of the questions I had earlier from Brooklyn was, when are we going to have our test? Okay. Our test is tentatively set for the Wednesday after we're back from spring break. The reason why, I know we're going to probably finish up. We're going to finish up notes tomorrow over this section. We'll get homework on that. Our one book segment of the week. We'll start reviewing Wednesday. We'll review Tuesday when we're back, and then we'll take the test Wednesday. That's kind of tentatively what I have set. So if you know you're not going to be here that Wednesday when we're back, we're taking a test that day, which is not a big deal. We'll just get you scheduled up. You'll probably get your practice guide tomorrow, even though we probably won't start working on it until Wednesday. Okay, does that make sense? So if you're not here Wednesday, you know what we're doing. You can watch the video. Okay, I'll post today's video up as well. Friday's video, I had an error with it, so I'll repost it. I need to redo it tonight to make sure that it works. It was not working right. It was all blurry and I didn't like it. So I'll make sure I'll refix that video and I'll recompile it. So, but goals today. On Friday we talked about trapezoids. We did the definition. We did a couple examples of trapezoids. I think we had to draw a trapezoid and stuff. We had that. We did a couple examples of kites. I think I did one of the examples in class was you had to outline the stealth bomber in class on Friday, where you had to show like the kite in the middle of that shape. We did some vocab words, and we started our theorems on trapezoids. You still need to be adding these trapezoids to your bubble. The bubble thing where we had all the definitions of the quads. You need to start adding these theorems in.
Okay, when's that due?
That, I'm going to make that due probably Wednesday, where we'll share it with me. Okay? Make sure you have an account and all that good stuff, and you'll just share it with me. Okay? It should have all your definitions, and it should have all your theorems. And I'll give those as points separately. Okay? But make sure, like today, we're adding these theorems. We have to get through the 24. Make sure when you're adding these to the bubble, you're attaching it to the right trapezoid. Because some of these deal with isosceles, some don't. So you gotta know which one to attach to. And we'll go through them one more time. Question?
My bubble is all kinds of messed up.
That's fine. You'll just have to clean it up before you submit it to me. You have a couple days to work on it.
It's terrible.
Well, clean it up before you submit.
Like it broke and then it fixed, but when it fixed, it broke.
Well, you have a couple.
It broke, so I made it like I improv.
Hey,
Kevin, no one likes you.
Hey, Kevin.
Yeah.
No one cares. Just fix it. Okay. Kites. Two theorems. 625, 626. Make sure that we're probably not going to get to these two today. I don't think. So these will be probably the ones we'll add tomorrow. Then we'll do some homework. We will get one book assignment tomorrow. I thought we were going to get to it today. Not going to happen. That book assignment will be due after we're back. Okay, and I'll kind of explain that one. It's pretty easy. It's just doing some of the stuff we've been talking about here. But we'll do more examples of that tomorrow in class. 621 to 624. This should be the slide that's on your nearpod, correct? Everyone's got this slide up on nearpod? Okay, let's get to 621. Now you should already have this theorem. This theorem should already be in there. I believe you have even some extra stuff that I won't have here, where it talks about the trapezoids isosceles. So this is an isosceles trap. The pair of base angles are the same. So this is the picture I had. You have a couple other things that are on the nearpod that explain why it works, like the proof itself. What we talked about on Friday on this one is how to prove it. Is we have to draw these perpendicular lines in there, because again, that's called the perpendicular posture. You can draw perpendicular lines to anything, and they're squeezed between parallel lines. We draw another perpendicular over here. And what it forces on Friday, we talked about that these two triangles, even though they don't look the same, they are equal. The reason being is that if they're right triangles, they share a hypotenuse, because we knew this was isosceles to begin with. The actual altitude is the same height, because that's the distance between the parallel lines. That's what an altitude is, a perpendicular. Because by definition of parallel, they're equally spaced, they're equidistant from each other, so these two sticks are the same. And by HL theorem, hypotenuse leg, we can actually prove that the triangles are equal, because they are right triangles, and that's one of our theorems. Once we have the triangles equal, then we can prove that the base angles are the same. Okay, that's what we talked about on Friday. And then what we also could do is transfer these numbers, these 90s, down to here, transfer those 90s down, and then we can get those other bases. Because we knew that these angles in here are equal as well, and if you add those to 90s, they still make equal angles. So those are the things we talked about on Friday. Question about this?
No, but.
Then no, I'm not gonna answer.
No, it's about
Nope.
math.
Nope, save it for later, Kev. We don't have time today, nor do I wanna answer it. So, moving on. Okay, 622, let's go to that one. Okay, 622, where's my cursor at? There it is. Okay, 622. On 622 itself, this is a picture I had. I didn't even like the picture, but it talked about the trapezoid has one pair of base angles being equal. We can prove that it's isosceles. This picture I talked about Friday, I did not like the picture of it. The reason being is that it's not the picture we used to prove it. Now, the only reason why I added it to the slide, other than it being in the textbook, is because it shows a picture of a trapezoid where the bases are going up and down this time. That's rare. The bases are the parallel walls. The legs are the two that match in this case because it's isosceles, that's what we're proving. But the picture we talked about on Friday was this one. We talked about this where the base angles were the same, that was our setup. Base angles has one pair of base angles. So what we did is we drew a parallel line in there using the parallel postulate. This is a parallelogram, so this wall can transfer over to here. And since this is a parallel wall, this angle can hopscotch to here, and it forces this triangle to be isosceles, so namely I can move that wall over. And that's what makes this whole trapezoid isosceles, that I can transfer the number all the way across. That's what we talked about on Friday. So if you have an isosceles trapezoid, we can move numbers and walls across. But I wanted to show you that picture because you got to get used to where the trapezoid doesn't always have to have the walls, the bases, always being going horizontal. They could be vertical like this. Okay, questions, comments about the theorems we talked about on Friday? Perfect. Jumping in, let's go to our next one. Okay, 623. Okay, 623. Okay, this, I believe this is new, correct? 623? All right, here you go. Trapezoid is isosceles if and only if its diagonals are equal. So the diagonals are equal. So I'll let you draw that picture. This is the picture I'm going to use to prove it. This is the one that I think most textbooks have this very similar picture. Now, they use the words if and only if. So below this one, you need to write the word biconditional. The word biconditional. That's what the word if and only if means. It means that you could write this sentence either way, and it would still work out to be the same. So I could write this, the trapezoid has diagonals that are congruent if and only if it's isosceles. So I could like rearrange the wording and it would still be true. So we are going to prove the fact. So we're going to start with just the first one. I'm just going to do the first way. So if we know it's isosceles, can I show that the diagonals are the same length? That's what I'm going to show. So we're going one direction, not the other way today. If you want to see the other direction, I can show you a different proof, but it's not very different. So it's a biconditional. Okay. Questions before I start here. Does everyone have the wording and all the pictures drawn? Okay, it's still a trapezoid, so it has parallel bases. In this case, we're going to start with the fact that it's isosceles, so you can put those marks on the walls, those wall markers. We're going to start with that fact, that the walls are the same. RS is equal to QT. Okay, are we good? So, okay, let's prove this. So here's the triangles that I'm going to use. I'm going to use this large triangle right here, RST. I'm going to use this triangle right here. And I'm going to use the other triangle that's overlapping it, which I'll try to put in green here. This triangle right here. So this is QST. These are the triangles that I'm going to use. They're overlapping. Now, if you look at each triangle, each triangle has one marker so far, correct? Like QS and the QT walls are marked the same. So each triangle has one marker in them so far that I can prove that they're equal. Second, both triangles share the bottom wall. What is that called where they share a wall? Starts with an R.
Rectangle.
Reflexive.
Yeah.
Okay, they share the reflexive wall. Okay, now the other thing that both triangles share, so they have two walls marked. The other thing that they share is because the fact that this picture is isosceles, right? It's an isosceles trapezoid. If we go back a couple theorems to 621, if you have an isosceles triangle, the base angles are the same. That's what we talked about in the first theorem. So that means this angle down here in the corner, that large angle here down in the corner, that base angle is the same as this angle over here. So the angle in the green triangle is equal to the angle in the black triangle. So that forces the two triangles to be the same because now I have three markers. In fact, what acronym does it spell? Yeah, SAS. So it is spelling that the triangles are equal by SAS. So if the triangle is equal, then boom, the diagonals have to be the same length. Because everything about the triangles have to be the same, including the third angles and all that good stuff. Okay, so I did prove without a doubt, if it's isosceles, the diagonals have to be the same because the triangles have to match. Okay, now here's the thing that I need you to be aware of. Okay, let me get rid of all these markers. Okay, so we just talked about the fact that the diagonal QS is equal to RT. Here's the thing you need to know, and maybe you want to make a note off to the side. This point right here, let's call it point P, right where the diagonals cross. It is not the center. It is not the middle of those pictures. Okay, does everyone understand that? It is not the perfect center. It's not a midpoint. What do I mean by midpoint? I cannot show you that this wall and this wall are the same. That it's like it split the wall in half. I can't do that. That's what happens on parallelograms, not trapezoids. It hit at a random spot. It's probably proportional, but it's not the perfect middle. That's what you need to be kind of aware of. Now, the other reason why I know it's not in the middle is look at this triangle down here. You see this triangle right here? This kind of isosceles looking one? That triangle is not the same size as that one. This triangle is really small. So since the two triangles are different, that means these walls are different. And so they're not the same, it's not the same length. So the diagonals are, not cutting each other in the perfect middles. So be aware of that. I know, for some reason people always think they cut each other in halves, they don't. Okay, let's move on. We have a new vocab word here today. A new vocab word.
Midsegment.
Okay, midsegment. So this should be on your nearpod, correct? Is it appearing?
Yeah.
Okay. All right, for midsegment, its definition. This is just a vocab word. It's fair game for the test. So this would be one of the words I can put in the word bank. You do not have to have it on the bubble for right now because it's not a theorem or anything like that. A midsegment for a trapezoid is a very specific type of wall. A midsegment is a segment that connects the midpoints of the legs of any trapezoid. So if you just have a random trapezoid drawn, a midsegment is a line that connects the middle of the legs. So I have a picture that's on your nearpod. Here it is. That's a midsegment. So if you have a random trapezoid where these spots are, this is like leg, let's call this leg 1, let's call this leg 2. Now why are these the legs? Why are those two the legs, not the top and bottom? Why are the right and left legs? Anyone happen to know? What's the difference between a leg and a base?
Legs aren't parallel.
Legs aren't parallel. So that's why the legs are right and left, because they're tapered towards each other.
The legs are what?
The legs are not parallel. So that's how I know where the legs are. So what we're doing is we're connecting the midpoints of these legs. So let's call this point right here N. And let's call this point over here M. Those are the middles. And you can see that. That's the middle of the stick. So it's the midpoint. Over here, you can see that those sticks are split in half. That's a midsegment. It's connecting the middles of the legs. So whatever drawing I give you, you have to find the middle of the legs, connect a line straight towards them. Got it? Now, you're probably thinking, okay, Ward, why do we need this? The next theorem is going to use this word. So we have to know how to draw it. Okay, is everyone good so far? Okay, everyone's got the definition and all that? Okay, so let me give you the next example here. So in your nearpod, you need to have that up because I'm going to have you draw. Okay, so I'm going to have you sketch. On this picture, I'd like you to draw the mid segment in there and label it correctly. Label the picture. Draw on your mid segment with your actual like markers and all that good stuff. So just physically draw it in there and submit it to me. Where's the mid segment on this trapezoid I'm providing you? Okay, make sure you label it, do the best you can, all that good stuff. Once you have it, label all that stuff, share it.
Will you show mine one?
If it's good, yeah.
It's good.
Put your name as Kevin.
You have to show mine. So hard to learn on these things, you know?
You can use text boxes.
That's cheating.
Okay, once you have it labeled, submit it to me, please.
Yeah.
I'll share good examples. I'll share ones that I can see errors on, if there's any.
Oh, wow.
Why? What? What do you mean?
Oh, yeah, there's a few more people to actually submit.
I need a hot second.
Just right on you, okay?
I messed up.
I'm gonna give you 5 more seconds.
There. See it? Show mine.
Well, if it's correct, I'll show it.
Don't look at it until you show it, though. It's
Do you
good.
have a paper clip on your tie?
I need a time clip, so I just use a paper clip. Okay. Alright, Kevin, I'll share yours.
What is this?
Correctly labeled, it is a mid-segment. He has the parallel walls, he has the walls that are marked the same. Okay, not bad. Now, probably not the most clean drawing. I think one of the most clean drawings is probably Brooklyn's here. Not
That's
nice
not
of them.
drawing.
Okay. So, here's Brooklyn's here coming up.
Bro, something
Okay, not bad.
Oh
Correctly
my,
labeled.
That's awful.
Pretty good, pretty good. Cut the legs in halves, you know, with M and N. Do the mid-segment in there. Okay. Here's one that I want to discuss that I saw, and it's a good drawing. Something's wrong with it. Not to pick on anybody, but this happened in the last class with a bunch of people. So I want to address it. Okay.
Rip. L.
It's just one subtle thing is off. What is it?
Stop. Is it the markers?
What?
The markers, like,
Yeah. the wall marker's off. Okay, here's why. Here's why the marker's off. When you draw a mid-segment, and you connect the walls like that, everyone was drawing that, that's fine. This wall is split here. The other wall is different. Okay, if you look at the picture I just shared with you, they have these two marked the same. That's not correct. Okay, because the walls are different sizes, but this is the midpoint of this wall, that's the midpoint of that wall, so they're different sizes. So the markers have to be different.
Isn't that still right though?
No, the marker they have, because we don't know what's isosceles.
But it is.
So,
Keep saying they. It's me.
well, there was a lot of people in the first class.
I did.
I knew it.
It's me. Oh, boy, out.
Okay, all right, let's move on. Okay, theorem today. Okay, 624. This one is by far the most challenging, because I said, when we got to 621 to 624, these four theorems are the hardest theorems to actually discuss, prove in geometry. This one in particular takes the cake. This is by far the most challenging theorem we've had up to this point. It is the most difficult one to prove in geometry. There's a lot of parts that have to go into this one. So theorem 624, if you're writing it down, I'll even go through the formula here with you because it is a formula. The mid-segment of a trapezoid is parallel to each base. So you're given that, you have parallel walls, and you can see that on the picture. But it's also 1/2 the sum of the bases. So I'll let you write that all down, and then we'll do a bunch of examples of this to show you how we can actually use this in the middle of a homework problem. So the mid-segment of a trapezoid is parallel to each of the bases, but the most important thing is that it's also 1/2 the sum of the bases. Okay, now this picture that I have on the board is a little deceiving. It's a picture of a trapezoid where it's turned on its side. So the bases on this particular picture, these are the bases. So base 1, this is base 2 over here. Okay, and this is the mid-segment. This is the segment going through the middle. Now, why I know that's the mid-segment? They said the mid-segment has to be parallel to the two bases. And you can definitely see that these are the legs, because they're tapered together. They're like gonna intersect down the road. Bases don't. So this is the midpoint of that stick, this is the midpoint of that stick. Okay, here's what it says you can do. If you know you have parallel walls, the measure of the mid-segment, this stick right here, is 1/2 the sum of those two. So if you take base 1 and you add it to base 2 and you cut it in 1/2, that gives you the mid-segment. That's what they're saying. So here's the numbers I'm going to give you. Let's say that this is an 8 and this is a 12. I can find how long that stick is in the middle. Because you add the two bases together, 8 plus 12. You cut it in 1/2. So 8 plus 12 is 20. You cut that in 1/2, and what's 1/2 of 20?
10.
10. Boom, this is 10.
Let's go.
So that's 10. Now, here's the other way to think about it. This is just common sense. It's the average of the bases. That's what it is. It's literally finding the average. If you need to write that word down, it's the average of the bases. That means you add the bases together, divide by 2. Well, that's what you're doing. Or, here's the other common sense way to think of it. It's the number in between them. That's what an average is. What's the number directly in between 8 and 12 on a number line?
10.
10. It's the perfect middle of those two on the number line. That's what the numbers are. That's what they're basically telling you. So if they gave you different numbers, let's say that they gave me a number, let's say that the number was 15 and this is 17. What's the number that's directly in between 15 and 17?
16.
That's the length of the mid-segment. Because if you follow the math and you actually do the steps I'm telling you, you add 15 plus 17, you add the bases, and you divide by 2. Well, 15 plus 17 is 32. And what's half of 32? 16. It does, the number in the middle. There's two common sense ways to think of it. Now, why this is important is because if you're given, two bases, you can find the midsegment. Or, I could do it this way. Let's say I had the midsegment. Let's say the midsegment was 11. Let's say it's 11. And let's say the other base is 17. I can find this other base using the same formula. That I add the two bases together and I divide by 2. And that gives me the number in the middle, which is 11 in this case. So I could go find the other one. So how I'd actually solve this, because again you add the bases to get the middle number and cut it in half. I'd multiply the 2 across, making 22. And I would subtract the 17 across, making this number has to be 5. Because 22 minus 17 is 5. That's how you could find the base if you were missing the base instead. Does that make sense, like the things you can do with this now? Okay, here's what I'd like you to do. On your nearpod, I'd like you to solve the problem and submit it to me.
We don't have policy, no.
Okay, I'm going to leave this up here. So we're doing a couple examples of this now. Okay, I'd like you to try one out where I give you a trapezoid, random trapezoid, because this applies to any of the trapezoids, this theorem. I would like you to find the midsegment length. And I think if you look at the directions in the little drop down, it tells you how long the bases are. I think on your problem, the bases are, what, 10 and 30? Those are your bases. I would like you to draw it, figure out the midsegment length without saying it out loud.
Almost done.
I want you to find the length of the midsegment. The two bases are 10 and 30. I want you to find the midsegment. So you can see that from the little drop down. Find it. Label it. Submit it back to me. I'd like you to find your answer, submit it back, please. Now we're going to talk about it. Already have one submission, just looking at some others.
Submit.
Okay, we're going to get it submitted.
Show
No.
mine, show mine.
Wait, I'm not done.
It's good.
Wait on two more right here.
Gordon, you gonna show mine?
Probably not.
Why?
It's hard to read.
It's not hard to read. Gives you a better understanding of it all.
Boom, alright, here's one I like. Very simple, easy, works. Okay? Okay, so let's talk about Trav. Why'd you get 20?
Because it's in the middle of 30 and 10.
Duh. That's the easiest way to do it. What's the number in between 10 and 30? 20. Boom, done. Move on. You don't have to overthink it. Now, there's some other people that shared it. They actually do the math, which is really good. Here's one that I saw. They had everything labeled. Okay? They're writing 20. I think they submitted too early. Okay. Yeah. But the idea is that they're doing all the math right.
Where do you get 40?
10 plus 30. And then divide by 2. They're doing everything correct. They just submitted before they actually finished out 20. Or they accidentally hit backspace before they hit submit. But again, that's how you find it. Okay, last problem of the day.
Wait, show mine.
No.
What?
Are we gonna have time?
Okay, yep, last one. I think we're out of here in like 2 more minutes, I think.
I think it's 1 more minute.
1 more minute? All
Yeah,
right.
it's 1 minute.
Okay, try it out. Let's see if you guys can figure it out. Okay, so on this one, I'm giving you one of the bases. I'm giving you the segment in the middle, the mid segment, and I want you to find the other base. Now, if the bell goes off, we'll just finish this one tomorrow. Yep. So, finish it tomorrow. So, one of the mid segments, or the mid segment I should say is 24. The other base is 18. Figure it out. Okay? Alright. Add some of those theorems.